Hi, my name is Lane Williams, and I am a biochemistry major from the class of 2020.
And my name is Sierra Gosting, and I'm a biochemistry major from the class of 2020.
We will be working through problem number 4 from chapter 3.3 in the general chemistry workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem. Then we'll go over it together. Let's begin by breaking down the components of what we're given in the question. We are told that the solution is 37.2% weight per weight. This means that there are 37.2 grams of HCl, the solute, per 100 grams of the solution. Within the solution, we have the solute and the solvent. HCl is the solute and water is the solvent. If we subtract 37.2 grams from 100 grams, we can find the grams of solvent. Now we have determined that we have 37.2 grams of HCl, which is the solute, 62.8 grams of water, which is the solvent, which makes a total of 100 grams of solution. Part A of the question asks us to calculate the mole fraction of HCl. A mole fraction is defined as the moles of A over the total moles. In the context of this problem, A is the HCl, and the total moles is the moles of HCl plus the moles of the solvent. Let's begin by finding the moles of HCl. If we have 37.2 grams of HCl, we can use the molar mass to find the moles. We'll do 1 mole of HCl per 36.46 grams of HCl. This is the molar mass. The result we get is 1.020 moles of HCl. We can do the same thing to find the moles of H2O. We have 62.8 grams of H2O. Divide that by the molar mass. We're left now with 3.485 moles of H2O. We can now use these two numbers in our mole fraction equation. So we'll put 1.020 moles HCl over 1.020 moles HCl plus 3.485 moles H2O. We get 1.020 moles divided by 4.505 moles for an answer of 0.2264. Our answer for part A is 0.2264, the mole fraction of HCl. On to part B, we are asked to calculate the molality of HCl. The definition of molality is the moles of solute per kilograms of solvent. Our solute is HCl and our solvent is water. The two pieces of information that we need, we have already found. We know that there are 37.2 grams of solute, which is the HCl, and we know that there are 62.8 grams of solvent. We can convert to moles of solute and kilograms of solvent using dimensional analysis. We'll divide by the molar mass of HCl, which is 36.5 grams per mole, and we'll multiply by 10 to the third grams, since there are 10 to the third grams per 1 kilogram. This cancels out grams on the bottom and the top. We are left with moles of solute per kilograms of solvent, and our answer is 16.23 molal. Moving on to part C, we are asked to calculate the molarity of HCl. The definition of molarity is moles of solute, which in our case is HCl, per liters of solution. Solution is the combination of solute and solvent. So in our case, that is the water and the HCl. We already have the two pieces of information that we need. We know there are 37.2 grams of solute, the HCl, and 100 grams of solution, which is the water and the HCl. We'll use dimensional analysis to convert to moles on the top and liters of solution on the bottom. What we need to use first is the density. This is given in the problem. It tells us that there are 1.18 grams of solution per 1 milliliter of solution. The grams of solution on the top cancels with the grams of solution on the bottom. Now we want to convert the 1 milliliters of solution to liters. In 1 milliliter, there are 10 to the negative third liters. This cancels out the milliliters on the bottom and leaves us with liters on the bottom. Now we want to convert our grams of solute to moles, so we'll use the molar mass of HCl. There's 1 mole per 36.5 grams of HCl. This cancels out the grams on the top. Our answer comes out to be 12.03 molar. Hope you enjoyed our video today. Thanks for watching.